Cool. Thank you so much. So just a heads up, it doesn't look like I can get video on the live stream, but that's fine. I'm still here for all of you guys. So for those of you that don't know me, my name is Nicholas Renaud. I'm a data science specialist at IBM, as Nathan was mentioning. And today we're going to be going through sales forecasting with profit. Now, if you've got any questions at all, like I mean, absolutely anything, do mention it in the Q&A or on YouTube chat. I'll be monitoring it as we're going through. Can see that we've got a bunch of people flowing in. Welcome. So in terms of what we're going to be doing today, we're actually going to step through we've skipped forward. We're going to go through some basics of sales forecasting. So in terms of our game plan, we're going to start out by loading some data into a notebook. So we're going to be using a Jupyter notebook for this. Then what we're going to do is we're going to train a profit time series model. So profit is a library which is being developed by the in-house data science team at Facebook. And it's ridiculously good for time series forecasting. Now, this could be forecasting weather, which is a little bit tricky to predict, but it might also be used for forecasting sales, forecasting anything which really has a time series based trend. So once we've gone to train that model, what we're then going to do is we're going to make a bunch of predictions and evaluate our performance. So we'll actually be able to do or perform a real-time training run and actually test this out in real time. Now, I've used this in a bunch of places. And funnily enough, I was actually talking to people on YouTube. This is one of the first Python libraries that I actually went about starting to learn when I was kicking off my data science journey. So feels like I'm coming full circle. Now, in terms of how this is going to be working, let's go to our next slide. And we don't seem to want to go to the next one. That's fine. So what we're going to do is we're going to load some data into our Jupyter notebook. Then we'll train our model with the Facebook profit package. And then last but not least, we'll go on ahead and make a forecast. So we'll evaluate our time series trend and make a bunch of predictions. But again, if you've got any questions at all throughout this, by all means, do mention it in the Q&A or just hit me up on the YouTube live chat. I'm more than happy to answer any of your questions. So let's actually take a look at our data to begin with. So I've just got a CSV document here, which has a bunch of information in it. Now, specifically, I've got 3 columns. So column A, column B, and column C. And in my first column, I've got a column called date. So again, it's really important whenever you're working with time series data that you've at least got some form of date or timestamp column, because this is what you're going to need in order to go and forecast the trend and actually generate a time series forecast. Then I've got a store and product combination. Now, you might tend to get data sets where you've got store and product separated. You might have multiple different columns. Now, in this particular case, we are going to train an individual model per store and product combination. Now, you can see here that I've managed to get my hands on some elusive Tesla model sales data. This is obviously made up. But what we've actually got is a combination of our store. So in this case, you can see this store is from LA over here. And then we've got a product as well. So in this case, we've got a Tesla Model X. All right, so it looks like we've got a question. So for later, do the dates need to be continuous or can they be gaps? Great question, Bill. So you can have ideally you want to have a continuous data set, but it can have gaps. Profit will be able to impute certain amounts of data. So it's core that you don't have giant gaps, but you can have some missing data and Profit can impute that. Just a core thing to note. Another question, is this a GitHub repository? It sure is, and I will share the link to that a little bit later. So you'll actually be able to pick up all of this code and take it away. I'll include the data as well. Okay, so we've got our store and products combination, and then we've got our values. So you can see here that we've just got a bunch of data, and I think I've got data for around about 3 years. So it starts out in 2018, so all the way back. And then if we look at one time series, let's actually filter this. All right, so you can see that we've got data for 3 different product store combos. So we've got LA Tesla Model S, LA Tesla Model X, and San Fran Tesla Model S. So if we take a look at one time series, so you can see we're starting at 2018. If we go all the way to the end, where are we ending up? I've obviously got data. Oh, wait, no, that's looking good. Where are we? So it looks like we've got data up until around the end of 2020. So we should be okay to go there. Now, what I'm going to do is I'm going to release that filter. Okay, so we've got some data. We've got a date column, we've got a store product column, and we have a value column. Now, what we can actually do is we can take this CSV, and keep in mind this CSV, I'm just going to move this out of my way. So this CSV is called dataset.csv. So if I actually show you this, let me open up my Data Science Dojo folder. So this is what our folder looks like. So we've got one file called dataset.csv, and then I've got our Jupyter notebook, right? So now it's time to get into a little coding. So great question, Gustavo. So is there a specific format for the date column? Yes. And what you'll see in a sec is that we're going to pre-process our data to make sure that it is in a date time format. So that's going to sort of help us out a little bit. But ideally, you just want to make sure that you're able to extract the year, the month, and the day as well. But I'll show you how to do this in a second as well. So you'll see how you actually need to process that. Okay, so this is going to be what we're going to be working through today. So first up, what we're going to be doing is installing our dependencies. Then we're going to load up some data. So in step 2, then in step 3, so this is for you, Gustavo. So we're actually going to apply some data pre-processing and convert our date column to a date time format inside of Pandas, or with our Pandas data frame. So you'll actually see this. Then we're going to create a time series model. We'll evaluate it. So we'll actually make some predictions. And then I've got some bonus code for you as well. So keep in mind that whenever you're creating time series models, what you tend to do is create one model per time series, right? So it is so we've got multi-time series data and we've got univariate data. So we've only got one column that we want to predict and one column that's going to be used as our input, but we've got different time series that we need to deal with. So the way that we normally deal with this is to create different models per time series. So we're going to create one for each one of our product and store combos. So I'll show you that right at the end. Okay, now let's actually quickly take a look at the library that we're going to be using. So we're going to be using Profit, whole bunch of information in here. It's really well documented. So if you want to see how we've gone and built this up, or if you've got specific things that you need to take a look at, whole bunch of information there that you can actually take a look at. And whose question was this? So MW, so you were asking if this is a GitHub repo. It sure is. So you can actually go to my GitHub repo. So github.com/knickknockknack/ what have I named this? Multi-store product forecasting space with space profit. I was naming that this morning. Probably a weird naming, but that's fine. So you've got all of the data there, right? And that includes the Jupyter notebook and the data set. So you're able to pick up all of that and leverage it if you want. Cool. So what we're going to do now is actually kick this thing off. So first up, what we need to do is import a few dependencies. So we've got 2 key dependencies that we need to import. So we need Pandas and we also need Profit. Now, there is one additional dependency that you can work with, and that is Plotly. So that allows you to have interactive visualizations. I haven't got that set up in this particular case, but that's fine. It will still work. So let's go ahead and import our dependencies. So those are our initial dependencies now installed. Sorry, I missed it. Value sales. Correct, Karen. So the value is sales. So this, probably should have called that out. This value is our sales value. Okay, so those are our 2 dependencies imported. Let's actually zoom in on this, make it a bit bigger. So the first line that we've gone and written is import pandas as PD. So this is going to import pandas. Import pandas. And so pandas, if you've ever done much data science, so this is or if you've ever worked with much tabular data, pandas is a really popular tabular data processing library available inside of Python. And it basically just allows you to bring in any sorts of tabular data. So say you've got a CSV, say you've got Excel, say you've got a JSON string that you want, or JSON object that you want to go and pre-process into a table-like object. Pandas is the library for that. Then the second line that we've gone and written is from FB Profit import Profit. So this is actually going to allow us to import the Profit library into our Jupyter notebook. So you'll actually be able to leverage that when it comes to forecasting your sales. So if we add a comment there, so this is going to be the Profit modeling library. Cool. So reasonably straightforward. So we've only got 2 key dependencies that we're going to need to bring in for that. And on that note, that's step one really now done. So we've now gone and imported our dependencies. Now, the next thing that we need to do under step two is actually bring in our data. So far, we don't actually have any data inside of our notebook. We've just gone and imported our dependencies. So what we're going to do is we're going to use pandas, so PD, to actually read in our CSV. So if we could go on ahead and do that. So actually, let's take a look at the read CSV function first. So if I type in read CSV, question mark. So you can see there's a whole bunch of options that we can leverage when bringing in data into our document using the read CSV function. But basically, the core function of that is to read in a comma-separated values file into a data frame. So that's exactly what we're going to do. And if you cast your minds back, remember our data set is going to be in the format of CSV. So that should be good to go. So let's actually do this. So what we're going to do is name our data frame DF. And we're going to bring in our data set. So I'm just going to type in the full path. So dataset.csv. And that's pretty much it for bringing in our data set. So all we need to do is pass through the full path to our CSV document. And that's going to come into our Jupyter notebook. So I've written df equals pd.read_csv. And then I've passed through the full path to that particular data set that we want to bring in. Now, if we go and take a look, we can actually review our data. So if I type in df.head, you can see that this is going to give us the first 5 rows of data inside of our CSV dataset. And again, this looks really familiar to what we were seeing when we were actually working with, or when we actually opened it up in Excel. Now, if we actually take a look, so who was it that asked this? So somebody, I think the comments have gone now, but it looks like, so one of the core comments, so Gustavo, you were saying that, do we need our columns to be in a specific format? We definitely do. And right now it's not in the right format. So if I type in df.dtypes, you can see that our date right now is just an object, which means it's just being treated as a string. So as of right now, we don't actually have any of the value or any of the richness of actually having a date column inside of our data frame. Right now, it's just being stored as a string. So we actually want to go on ahead and convert this into a date time format. And that is exactly the first data pre-processing step that we're going to do inside of step 3. I'll pause there. Are there any additional questions you guys shooting stuff through? Doesn't look like we've got any that are unanswered. Okay, cool. We can keep going. So let's go on ahead and do a little data pre-processing. So the main form of pre-processing that we're going to do is we are going to convert our date column into a date time format. So we can do this using the toDateTime method from Pandas. So if I type in pd.toDateTime, so basically the core thing is that this is going to convert a particular argument or column into a date time format within Pandas. So again, really straightforward to actually get this done. Looks like we've got a question on YouTube chat. Will the data set be shared? Sure will. It's available via GitHub, so you'll be able to pick it up here. So what were we doing? So we're going to use the datetime function to convert this from a string to a datetime format. What we also need to do is we need to filter out one store and product, because remember, the profit package is only going to work with one time series at a time. So we need to filter down and single out one specific store and product. And one of the nuances with actually working with profit is that you need the date column to be called DS, and you need the sales or whatever your time series value column to be called Y. So we're also going to do that. So basically, there's a few different steps. So we're going to convert our date column into a datetime object. We're going to filter out on the store and drop this column. We're then going to rename our column names as well. So this will become DS and this will become Y. All right, so let's do the first thing. So let's actually go and convert our date column. So I'm going to overwrite our existing date column. Right, so remember, when we're working with Pandas, we can filter out on a single column just by identifying the column name. So just by typing df and then passing through the index date, this allows us to filter through. Then what I can go ahead and do is actually apply some processing on that, or override it effectively. So we're going to use pd.toDateTime. And then we're going to pass through the column that we want to apply that toDateTime formatting on. So if I type in df.date, you can see that has now gone and pre-processed our column. Now, you can't actually see anything yet because I haven't shown you. But if I type in df.dtypes, this has now gone and converted our date column into a date time object. So we can now actually begin to work with that. So if we actually take a look, let's make sure that we've actually got all of our data. So if we type in df, so you can see that our date still sort of maintains some semblance of structure. So you can see down the bottom, the last value is now reading as 2020 12-16. I wish I'd actually kept it the same up here so I could have shown you, but it's still gone. You can, actually first row is sort of valid. So you can see that the first value in over here is the 1st of January 2018. You can see that's exactly the date format that we've got over here. So the first, in this particular case, it's going to be year, day, month. So the 2nd of January 2018, 2nd of January 2018, 3rd of January 2018, 3rd of January 2018, so on and so forth. So we are good to go there. Now, the next thing that we want to do is we want to create or isolate our data specifically for the specific store and product combo. Because remember, I was saying we want to isolate the single store product combo because that's what we're going to generate our forecast on. So let's actually go ahead and do that. So what we'll do is we'll actually apply some filtering and we'll take a copy of this data frame, of the specific part of our data frame that we need. So we're going to call it frame, and let's go on ahead and do this. So we're going to create a filter on our store and product combo. And let's just say for now, we're going to grab this store and product combo. So we're going to grab LA and we're going to grab the Tesla Model X. We don't have the Roadster in stock yet. So what are we doing there? So I've written frame equals and then df. So this is going to, let me actually show you this. So this is akin to effectively just filtering, right? So I've written df and then inside of here, this is my filter. So I'm basically saying on the df store / product column, I want to filter out and only bring back rows which meet the conditions of being Los_Angeles Tesla _model _X. So this is effectively going to filter our data frame. Now, if I take off this filter, right? So if we take a look at all of our data, so right now with our filter on, we've got 1,080 rows. If I take the filter off, we've got 3,240 rows. So you can see that a filter definitely has been applied. And if we actually go and apply some or take a look at our unique values, so if we go and filter on store again, you can see that we've only got a single store product combination there. So we are good to go in that respect. Now, what we actually want to do is we want to save this as a new variable. So rather than having just a in-memory capture, we actually want to store this as a new variable so we can begin to work with it. So we're going to call this slice. Actually, let's not call it slice because that's reserved. We're going to call it frame. So our frame is effectively going to be a copy or a slice of our entire data frame. Now, what we want to do to make sure that we're not partitioning this or we're not actually just applying this in memory is we're going to, or not in memory, we're not applying it in place. We're going to create a copy of this particular data frame by passing through .copy over here. So now if we take a look at our data frame, this is our data. So we are good to go. So we've at least got a slice of data now that we can begin to work with. Now, so far, let's actually take a look at what we've done on our data pre-processing. So we've gone and converted our date to a date time object. We've also gone and taken a slice of our data and made a copy of that. Now, the next thing that we want to do is drop this column because we don't need that anymore, right? It doesn't actually add any value because we've only got one store and product combo. So let's actually drop this. So we can use the drop method for that. And I'm going to say what column I want to drop. So store / product. And because we're dropping on a column, we need to pass through, we need to set the axis. So by setting axis equals 1, we're effectively saying drop a column, not so much a row. And we're going to apply this in place. And that should effectively go and perform our drop. So let's take a look at what we wrote there. So I wrote frame.drop, specified the column that I want to drop. So that's our first argument. And then I've gone and specified a couple of additional keyword arguments. So I've specified axis equals 1 because we want to drop a column, not a row. And then I've specified in place equals true because we want to go and apply it on this data frame. We don't want to create another copy of it. So if we go and run this now, can't see anything yet, but if we go and take a look at our frame, you can see that we have in fact dropped that column. So we're now good to go. All right, so we've got our date and our value. So we've gone and applied 3 different sets of data pre-processing. So we've gone and created our date time column. We've gone and created our frame or created a copy of our frame. And we have also gone and dropped our store and product combo. Let's take a quick look at our question. So do I need to install Facebook Profit? I seem to run into an error when I ran the first line, if install Facebook Profit. Do I have to install Python? So yep, so you got to install Python. If you're running on a Windows machine, take a look at the min.gw compiler that hopefully helps that go and transform correctly. So Joe, did the date conversion happen correctly? The original dates were daily, but now they look like they're monthly. So I checked this previously, so it has happened correctly. So it's gone and converted it. So in this particular data frame, I actually had it as, what did I have it as? Day, month, year. When we go and apply it, this data pre-processing, it goes to year, month, day. So again, should be fine. You'll see this impact once we actually go and produce the forecast. Cool. All right. So what do we have to do now? So then the next thing that we would need to do is go and rename our column. So right now it's specified as date and value, but we need to go and flip these around or rename them effectively. So let's go and perform this last data pre-processing step. So we're going to set frame.columns equal to DS and Y. And that is our last data pre-processing step now done. So if I go and delete this, so you can see that we've now got our date and we've now got our date column, and we've now also got our sales column. So we are now effectively good to go with our forecasting. Okay, so that is, let's quickly go and recap. So in terms of our data pre-processing, we've gone and converted our date columns to a date time format. We've then also gone and performed a filter on our data frame to single out one specific time series. And then what we've gone and done is we've gone and dropped our store and product column to make sure that we've only got one time series that we're going to be working with. And then last but not least, we went and renamed our columns. And this is our output. So we've gone and taken this over here and transformed it into this, which is now ready for us to pass to our time series model. So let's go on ahead and do this. So right now we don't actually have anything under step 4, but we're now ready to go and produce our model. So let's do it. So first up, what we're going to do is we're going to create an instance of the profit package or profit class. Cool. I'm just going to grab a sip of coffee. Okay. And then the next thing that we're going to do is we're actually going to go, let's actually take a look at what we wrote there. So basically I've written M, and M is going to represent our model in this particular case. And we've set that equal to the profit class. Then we've also gone and passed through one argument, and we've set our interval width, and we've set that to 95% or 0.95. Now you can play around with this if you wanted to, but in this particular case, this is sort of like the baseline model setting that you might choose to tune with. Now, the next thing that we actually want to do is we actually want to go and train our model. So again, pretty similar to how you might go and train a scikit-learn model or how you might go and train a TensorFlow model. It's going to be fit and predict. So we're going to store our model inside a variable called, we're going to store our training results inside a variable called model. And this could be called training run. And we are going to run m.fit on our data frame. So remember, we named this over here frame. So if we go and run this now, that's our model now trained. So you can see that it went reasonably quickly. So that's pretty much it in terms of training. So I've written training underscore run, and I've set that equal to our training run. So m.fit, and then I've passed through our data frame. In this particular case, no, so I'm not doing a train test split over here, Sean. So we're actually going to evaluate on basically everything that we've got, and then we're going to push it out. You could go out and split it out, but in this particular case, we're actually going to produce a future split and push this out. Again, you could pump out this entire model or pump out this particular run and make it significantly longer if you wanted to. But in this particular case, we're just going to train on all of our data. Okay, now the next thing that we want to do is we actually want to go on ahead and make some predictions. So let's go on ahead and do this. So first up, what we need to do is make a future data frame. So what is Profit doing in the background? Is it using a neural network? So no, this is using specific time series algorithms that have been developed by the Facebook team. So again, whole bunch of information on this if you want to see as to how it's actually gone and been generated. And sort of, who was it that mentioned? So Joe, so you can see that this is sort of the date format that the Profit was expecting. So year, month, day, which is exactly what I had. And then it went and transformed it. But again, if you do pick something up which is not quite right, do mention it in the comments below. I'll update the code if you've seen something there that's not quite right. But in this particular case, we're going to power forward. So the next thing that we want to go on ahead and do is evaluate our model. So first up, what we're going to do is we're going to make a future data frame, and we're going to store that inside of a variable called future. Then we'll actually go and make a prediction, and then we'll go and push this data out. So let's go on ahead and do that. So in order to make our future data frame, I'm going to create a variable called future, and we're going to set that equal to m, which in this particular case is our model from up here. And we're going to use the make underscore future underscore data frame or method to actually go on ahead and do that. We can then go and set how many periods we want to generate. So I'm going to set periods equals to, I don't know, let's set it to 200. So this is effectively going to go on ahead and forecast for 200 days forward. Then I can specify my frequency. So I'm going to set that equal to daily. And so that's our future data frame now created. So if I type in future, you can see we've got all of our future data frames going all the way out. That doesn't look like it's actually gone far enough out. So let's look at our tail. So that's out to 2021. So if we take a look at our tail, you can see that those are the data frames that are appended to the end. So if we actually take a look at our head, this is going to include our initial training data or initial training data dates. So you can see out to 2018, if we go all the way to the end, all the way out to 2021. Now, the next thing so you can see that basically if you wanted to go and train for or go and forecast for longer periods, you could push this out to 400. And you can see that we're now generating future periods, which are further out, right? So again, you can push this out a whole heap further if you wanted to. Now, in terms of actually going and generating this forecast, all we need to do is run. So remember, to train, it's just m.fit. To actually go and forecast forward, it's just m.predict. So what we can do is we can create a new variable called forecast to hold our forecast. And what we're going to do is we're going to set that to m.predict. And we're going to pass in our future data frame in order to generate that forecast. And that is our forecast now generated. So if I now go and take a look at our tail, so forecast.tail, you can see that we now have our future forecast now pushing out there. So we've got a whole bunch of information here. We've got our date, which is our date column, and we've also got our, which is most important, we've also got our Y hat column. But you've also got a whole bunch of additional information. So you're able to take a look at the trend. You're able to take a look at the upper, the lower bounds. You're able to take a look at the specific trend components. So trend lower, trend upper, your additive terms, your weekly values or your weekly trend components, so weekly value, weekly lower, weekly upper, yearly lower, yearly upper. You've also got multiplicative terms, but the most important column is going to be this Y hat column. So your Y hat column is effectively what actually represents your forecast in this particular case. Now, if I actually take a look at our head value, so right now we've got our, so if I scroll out, so we've got our baseline value, which was, it doesn't look like we've actually got that. Let's actually bring it in. So df.head or frame.head. So you've got your DF or your frame, original frame that we actually went and trained on. So in this particular case, our Y value was 2,926, and our forecast was sort of saying we've got around about 2,802. So not perfect, but what you'll actually see is when we go and visualize this, you'll actually be able to see the trend behind it. So let's go on ahead and actually forecast this out. So let's actually go and visualize it. So if I type in plot, so let's actually specify our plot. So we're going to save this. So plot1 equals m.plot. Oh, let's actually take a look at what comments we've got. So where did I use 0.95 as our interval width? So that's just our confidence interval that we want to use, or how confident we want our model to be. What type of model is being used in the back end? I haven't actually taken a look at what models are used in the back end, Daniel. I've just sort of used the package. I can actually get you some information on that if you want more detail. What else do we have? Have I missed anything? Good to know. Another cool thing is that there's actually a library called, sorry, I was just reading the comments. So Prophet uses an autoregressive model, but uses Fourier transform on the training data to estimate the best parameters. Thanks, Mehdi. So you can also take a look at another Prophet-like package, which is called Neural Prophet. And the cool thing about that is that actually uses an ARNet neural network behind the scenes. So it's actually, again, so it's sort of based on this, but it's actually using deep learning in the background. Can you show the data and prediction line on a graph before the future data frames? Yeah, so this is exactly what I'm going to do now. So I'm actually going to show you what this looks like. So let's actually go on ahead and do this. So what do we have? So we've got our plot, and now all we need to do is pass through our forecast. And there you go. So you can now begin to see how our model is generating a prediction. So you can see that we've got a large number of forecasts sort of towards the bottom here. It's now shooting up. And keep in mind, this is our training data. So all the way up to here is our training data. Cool. And you can see that it's actually mimicking this trend. So a large majority of our forecasts are towards the upper bound. So it's actually going and predicting that. This blue line is actually our forecast. That's actually Prophet doing that forecast. So you can see it's starting to mimic the trend that it's actually seeing, and it's in the actual data there. Right? Cool. Any questions on that? So that sort of gives you, have you tried, so we've actually got a question there. So have you tried Neural Prophet? Is it faster in model fitting? It's actually a bit slower, Mehdi. So that's just a key thing to note. But again, it's still pretty cool as well. It's not as well supported as Facebook Prophet, but again, there's quite a fair bit that you can do with it. Okay, so what we're going to do next. So let's actually take a look at what we've done here. So under our evaluate model method, we've now gone and made our future data frame. We've then gone and made a bunch, taken a look at our results, and then we've also plotted them out. Now, the last two things, or the last thing that we're going to do, is actually take a look at our different trend components. So we can actually break down our trend, or the trend that we've actually got in our time series, using the plot components method. So if I type in plot2, so we're going to save this plot2 equals M, and then let me zoom in on this, for components. And then if we pass through our forecast again, this will actually break down our sales forecast into its individual components. So you can see here that it looks like from a yearly period, or overall, we've got an upwards trend, and you can see that that's replicated when you actually take a look at our data here. So it sort of starts out a bit lower, and then we end up heading towards an upward trend. If we go and take a look at our weekly trend, or what is this? Yep, weekly trend. So you can see that on Sunday, we're sort of starting up, we're dropping a little bit further down, and then on Wednesday, we're sort of hitting our low. Thursday, we spike, and then Friday, Saturday, Sunday, it looks like, or Friday and Saturday, it's spiking. So again, this might be indicative that people are buying more Teslas on Thursdays, Fridays, and Saturdays. So again, they've got a little bit more time, and they can actually go and spend more time going and shopping around. So on that note, that is pretty much the crux of this tutorial done. Let's actually take a look. I'm going to show you how to do it with multiple time series in a sec, but let's actually take a look. You have more than 1 point per data. Now, I believe we've got one, but Carlos, if you're picking up that we've got more than one data point per data, that might be, I might just need to fix up that data set in that particular case. Good pickup though, if that is the case. I got to double check for you, but if it is, awesome. So what else do we have? Have you tried splitting the training data into test and training data? I mean, can we split? Yeah, so normally I'll actually split this out, but in this particular case, I've just gone and thrown everything to it. So best practice would be to split out your training data and testing data separately, and then going and potentially performing like a mean squared error analysis on the, on the test data, on the looking at your testing partition versus what you've actually gone and predicted. So your Y hat. Can you include other features columns, for example, buys, add buys, and see how they impact the model? So that is beginning to get into the realm of multivariate forecasting. So you can actually add this thing. So let's actually take a look. So you can actually add in a whole bunch of additional information into your forecast. So you can actually add holiday effects, regressors. You can also add in, what was it? There was, what was I looking at before? Might not be here, but I was actually taking a look at whether or not you can apply. So ad spends is a really good one, but holidays is probably an even bigger one. Ad spends, you might actually take a look at performing a look at other techniques for that, but you could definitely add leading and lagging regressors. So that might be another thing that you choose to add in. What else do we have there? Seasonality. Yep. So seasonality is sort of built in. I'm just looking at the comments here. Okay. So where are we now? So again, there's a whole bunch of additional, I've sort of gone through this at a very high level, but you can definitely go into it in a whole heap of additional detail. You can add holiday events. You can add change components. So say, for example, you know that there's going to be a change in trend. Say, for example, you had COVID, and that was obviously going to throw out your data. You can actually add change, I believe is here. So trend change points. So this actually gives you the ability to go, hey, at this particular or in this particular time period, something's going to shift, and we need to make sure that we actually cater for that so that we can actually adjust our time series going forward. So you can actually build that in as well. So what's the score of prediction? So you can actually, so Francisco, so that was your comment. So you can actually get the Y hat value out of here. In terms of going and performing like a MSE test, you could just bring that in from scikit-learn and compare your Y hat against what you've got inside of your base data frame. Because keep in mind, when you go and produce this forecast, it's actually going to go and bring all of your, or it's actually going to make a forecast for your training data as well. So you'll actually see that there. So these dates are actually part of our training data. Any questions I haven't answered? So Sean, I'm just trying to think about your particular question. So can you include other data features? I haven't done that myself. You could probably try to build that in as a leading regressor. I mean, to be honest, if I've got some ad spend data, I'd probably start doing that. It might be indicative of the fact that it's no longer a purely seasonal data set. So you might choose to model that slightly differently. But again, hit me up in the comments below. I'd be interested to delve into that one a little bit more detail, but not something that I've traditionally done with Profit in this particular case. Okay, what's our last thing that we need to do? So we've now gone and done a bunch of stuff, right? So let's quickly recap. So we went and imported our dependencies. We went and loaded in our data. Yeah, I didn't split it into training and testing, but you could definitely do that if you wanted to. Just keep in mind, when you're splitting into training and testing, you're not going to be doing a standard random split. So you'd actually be partitioning on segments of your data. So you'd actually need continuous data sets. So what you might choose to do is you might choose to train on, I don't know, 2 years of data, and instead of actually going and so train on 2 years of data and then go and forecast out on the rest of your data in that particular case. Do you really appreciate the Q responses? So another question from Sean. So really appreciate the Q responses. Do you know if Profit automatically discounts the value of older data? No. So what it actually does is it factors that into the trend. So it's actually, so even though we've got lower trends, so it's actually estimating what's happening over time. So older data is still very much important when you're actually using or actually building this into the model. Key thing to note though is that if you've got change points, so say for example, right, I'm trying to think of a business that has probably been hit. Say for example, I'm a hospitality retailer, and I know that, or say for example, I'm a pub, even better. So I know that I'm going to sell 3,000 pints on average per day. I'm obviously going to have a bunch of seasonality in there. I'm going to sell more on weekends. Now, COVID hits, and you know that there's going to be a huge shutdown. What you might choose to do is actually configure a change point and go, hey, once COVID hit, we're actually expecting a change in our trend. So you might actually choose to change or allow Profit to actually retrain over that change point period. So this means that you'll actually be able to see the impacts of a downwards trend or COVID actually hitting during that period. So again, there's a whole bunch of additional stuff that you could do there. Okay, so the last thing that I wanted to go through was how we can sort of scale this up. So remember when we went and took a look at our data set, we had 3 different product lines. So we had stores and products, and we only took a look at, what did we take a look at? Lossa_Angeles, and then we took a look at our model X's. So how would we actually scale this up? So I'm not going to write this code from scratch because there's a bit here and we've already gone through, what are we at? 44 minutes. So what we can actually do is we can actually extract all of our different product and store combinations. And remember, I did this a little bit earlier before. So if we type in df and then pass through the index that we want to process, we can grab all the unique values by typing in .unique. So this is actually going to extract this out. So you can see by doing that, I've extracted all of the unique product combinations. So in this particular case, LA Tesla Model X, LA Tesla Model S, San Fran Tesla Model S. Now, in this particular case, we're dealing with, I don't know, so it's going to be Tesla. So it's an automotive company, but this could just as easily be a whole bunch of different SKUs in a supermarket. It could be, I don't know, drinks. We were talking about pubs. Could be, say, for example, you got a whole bunch of pubs that you want to forecast sales for. You could definitely do that and forecast food and beverage sales versus other streams of revenue. So you've definitely got the ability to do that. Great question. So I just saw this question pop up on the YouTube chat. So if it was sales data, would you choose to transform or normalize the 2020 data during COVID in some way? Talking to a large number of my clients, what they're actually choosing to do is to exclude COVID, the 2020 data entirely from their sales data because it was an extraordinary period. And ideally, if everything sort of starts shifting back to normal, they're not expecting that to repeat. A large number of them are actually excluding 2020 entirely from their sales forecast. So you've got the ability to sort of do that. You could configure a change point, but the only thing is that once COVID sort of actually steps, or once COVID sort of ends, you might expect the trend to actually go back. So you might choose to configure one change point for COVID hitting and one change point for the impacts of lockdown opening back up. So that's potentially what I'd be doing. So I'd actually be configuring two or excluding the data entirely, depending on what type of business it is. So normally you'd like to go and tune depending on how you actually see your model coming out that way. Okay, what are we up to now? So the last thing that we want to go on ahead and do is actually, so we were actually doing this for multiple products. Now, let me explain what's actually happening here. So we're actually just looping through all of our different products. So if I actually show you this, let's zoom out. So if we go and type in force, stock line, in lines, what we're effectively doing is we're just looping through each one of our different product store combinations, stock line. So you can see there that by looping through all of our different lines inside, or all of our different stock lines inside of lines, we're effectively just grabbing a string in this particular case. Now, in this particular case, what we're going to do is we're going to store our fit models inside of a dictionary called fit_models. So this is pretty similar to how I'd actually go about training a number of machine learning pipelines when I'm using scikit-learn. So I'll actually, did Profit give Facebook access to your proprietary? No, so it's all open source, Sean. So that's a key thing to note. So it's all stored locally. You don't, once you've gone and installed the package, you can actually disconnect from the internet and just run it locally. So again, it's you can safely use it. What were we talking about? So fit_models. So you can actually store your models inside of a dictionary called fit_models. And again, this is similar to how I do it with scikit-learn. So what we're then going to do is create a new instance of our profit class, exactly the same as what we were doing right up here. And then we're effectively just going to replicate our training pipeline. So we're going to create an instance of our profit class. We're then going to fit our data on our frame, and we're not actually filtering this out, so we need to do that. So let's actually go and do that. Should have taken a look at my data, Nick. So we actually want to go and isolate our data, and then we're going to drop our column. So what we'd need to do is we'd need to go and isolate our column, and we're going to go and ahead and do that. And so what we're doing is we're effectively just filtering out on our data. So if we go and perform that filter now, so we're going to set it equal to stock line, and that's going to make a copy of our data frame. And then we need to go and apply our transformation again. And then we also need to go and reset our column names. So you can see here that what we're doing is we're effectively just going and replicating how we went about training our initial model, but rather than doing it individually this time, we're actually going to go on ahead and loop through and train on our individual stock lines. So this first line that I've actually gone and written here is we're actually going on and filtering out on our store and product combinations. So remember, we're going to be looping through each stock line from up here. And so we're going to create a filter for each one of those different stock lines. So when we go and loop through, so let's actually take a look. So say I go and copy this. And then if we go and run, let's go and print out df.tail. So what we're actually going to be doing is looping through. Am I actually filtering through on that? No, I'm not. What's happening there? Oh, frame.tail. So what we're actually doing now is we're actually looping through each one of these different product combinations. So in this particular case, we've got store and product, and we're actually going and outputting the last couple of results from each one of those product lines. Now, if we go and do that over here, we're effectively going and resetting our frame to the new product line each time we actually go and run through this. So we're going to go on ahead and drop our store and product column, and then we're going to go and reset our column names as well. So DS is going to become our date column, and Y will be our Y value column as well. And then we're effectively going to go on ahead and fit on this frame. So let's go and set that there. So if we go and run through that now, we should effectively, and then this last line is quite important as well. So once we've gone and trained our model, so remember we've got model equals m.fit, and we're passing through our frame. We're then going to go on ahead and set our model in, or push our model into our fit underscore models dictionary, and we're going to set that equal to m. So if I go and run through this now, it looks like we've got an error. Data frame has less than 2 non-NaN rows. So it looks like we're getting errors there, but that's fine. You can effectively just go on ahead and loop. So I'm guessing there might be some issues with our data. Let's actually filter add lines. Let's actually do it on our first two. Looks like this data set, we might be missing some data there, but that's fine. Let's actually just loop through our first two. So lines equals lines are 2. Okay, so there you go. So I've only gone and trained on 2 models. Looks like somebody said that there might be some duplicate data, or we might have more than a particular indication for one particular date. So it looks like there might be something wrong with our data there, but that's fine. You can still go and loop through your data sets. So I've gone and isolated the 2 data sets that we're going to work with. So if we go and type in lines, you can see that I've got loss underscore Angeles, and then we've gone and specified. So we've now got our model X, and we've now got our model S. So if we go and loop through now, you can see that we don't have any issues there. Now, if I go and take a look at our fit underscore models dictionary, you can see that I've now actually got 2 different models saved. So this is sort of how you might actually go and loop through and actually generate a large number of different models. Now, if you wanted to access a specific model, we can actually isolate these. So if I go and copy this particular one, you can see that I've now got 1 model. And again, as per usual, we can make a future data frame. So which is effectively what's happening here. Let's actually just do it there. Right, so what we're actually doing here is we're first creating our future data frame. So in this particular case, I've typed in forward equals fit underscore models, and then we're isolating out the specific model that I want. Because remember, inside of our fit models dictionary, we're now going to have more than 1 profit model actually saved. So this is a separate model, and then this is a separate model over here as well. Now, in this particular case, we're going to make our future data frame. So no different to what we were doing over, where is it? Over here. So these 2 lines are effectively the same, right? So we're creating a future data frame, and then what we're going on ahead and doing is performing a forecast on that. So if we go and run this now, we're now going to have a forecast generated. And so this is a forecast done using this model. If we wanted to go and do it on our Tesla Model S model, we could do that as well now. So I can go and grab this, paste it in there. And we've now got a new model generated as well. So again, this is now going and doing it on, or we're now forecasting for Tesla Model S's instead of Tesla Model X's. On that note, that is everything that I wanted to show, sort of done in a nutshell. So let's actually take a quick recap, and then I'll answer a bunch of additional questions if you guys have any. So we first up went and imported our dependencies. We then went and loaded up some data. We then went and applied our data pre-processing. And remember, we went and did, what is that, 4 specific things. So we went and converted our date column to a date format. We went and isolated a specific time series that we want to go and forecast for. We then went and dropped our store and product column, and then we went and renamed our columns to DS and Y, which you can see there. We then went and created a time series model. We went and created a bunch of future predictions. And if you wanted to, yeah, I didn't actually go and split out the data into training and testing, but you could definitely do that if you wanted to. Just keep in mind that what you want to do is you want to split on time, not just do a random split in this particular case. So rather than splitting randomly, you'd actually go and potentially take the 2018, 2019 years and go and test out on 2020. And then we went and plotted out our forecast, plotted out our components, and then I sort of gave you an idea as to how you might go and scale this up if you had multiple time series that you needed to go and forecast for. All right, let's take a look at our questions. So what did we have? So Gary, do I use Profit in my role at IBM? So I actually use this for, I actually work really, really closely with a data simulation, or a piece of software that actually does data simulation and data modeling. So I actually use this, integrate with the API for this or use Profit with that API quite a fair bit. So yes, I definitely do use it at IBM as well. What other questions did we have? I'd use dummy data variable for 20. Oh, so I'm just reading the comments. So it looks like we've got a whole bunch of comments as to what you potentially could do. So whether or not you could use a dummy variable for 2020 data points, definitely could do that. So this is an interesting question. So, and this is coming from Carlos. Carlos, I think you were the person that called out whether or not we've got more than 1 point per data set. I'm going to go and check that. So if that is the case, I'll go and fix up that data set for you guys so you can pick that up. In the case of forecasting a huge number of SKUs, say, for example, more than 1,000 SKUs using this loop, would you say this is going to be prohibited in terms of running time and whether or not a GPU would help? To be honest, you can see that it's actually pretty quick. So I've done this for up to like 100, 120 different SKU and product combinations. So you should still be okay. If you're getting to the point where you're getting to thousands of SKUs, what you might choose to do is you might choose to separate out your data frame. And rather than just doing a loop, you might actually have a proper training pipeline set up if you're going to do that in that particular case. What else did we have? Any other questions, guys? Nope. Okay. All right, let's quickly take a look. So what we did is we went through a bunch of stuff. So we took a look at how we can load our data in a notebook, how we can train a Profit time series model, and how we can go on ahead and make some predictions and evaluate our performance. Now, again, there are a potential number of improvements that you could definitely make to this. So you could definitely split it out into a training and testing partition. It's probably good practice to also run a bit of evaluation. So I'd suggest taking a look at MSE and see how far your predicted values differ from your true values. So again, you could just use the MSE metric out of scikit-learn for that. And then in terms of how we went through it, so we loaded our data into Jupyter, we went and trained our model using Facebook Profit, and then we actually went and made some forecasts. And again, all this code, including the data, is going to be available via Profit. And if you've got any questions or any issues, by all means, do hit me up. So I do have a YouTube channel, so you can definitely go and take a look. And all right, one last question. So would you review what you need to have installed to be able to utilize Profit? So in this particular case, you need to make sure that, I'm operating inside of a Jupyter notebook, so you could definitely do that. Potentially use Anaconda as well. You're going to need PyStan to be installed, and PyStan has a dependency on I believe, a C++ compiler. So if you're running on a Mac, you should be good to go. If you're running on a Windows machine, you need to install something called MinGW. So this is going to be the C++ compiler that you're going to need in that particular case. Might just be easier to use the Windows subsystem for Linux in that particular case. But so what did I say? So Jupyter, PyStan, and then you're going to need to install Facebook Profit as well. So should be all good to go with that. But on that note, that about wraps it up. Nathan, I will throw it back to you.
Hey, Nick, thank you so much. I hope everybody really enjoyed themselves. And based on the questions, I think they all did. Nick, I just want to say, hey, thanks for being here. On Wednesday, we're going to be hosting another webinar on an introduction to deep learning with PyTorch. And our presenter on Wednesday is going to be Jerica Borovic. a senior research engineer at grid.ai. And in that talk, Jerica is going to go give a quick overview of deep learning and then dive into some examples using PyTorch Lightning. If you're interested in attending that, I'll be posting the link in chat here in just a second. Again, thank you, Nick, and I hope everybody has a good rest of their day.
Thanks so much, Nathan. Thanks for having me, guys.